So it's 10 o'clock. Welcome everybody to this new webinar of the new 5G-ACIA series webinars 10 at 10 it's called. So of course it's the 10th of every month at 10 o'clock in the morning, of course, but I realize it could be afternoon for some of you who joined. So good morning and good afternoon depending on the time zone. My name is Andrea D'Aquino. I am the working group number 4 chair within 5G-ACIA. So this is the working group taking care about marketing and liaisons. And once again, I would like to welcome you to this new webinar on business value and return of investment calculation for industrial 5G use cases. A couple of housekeeping statements. Of course, web questions are welcome, and please submit them either in the Q&A window or in the chat, and we will try to answer as many as possible as long as the time allows. Should any question remain open, then please sign up in 5G-ACIA to get them answered, or you can see the link there, or you can email at the displayed email address. This meeting or webinar will be recorded, and the recording will be made available on our website afterwards. For the time being, everybody is muted by default. So again, if you need to say something, please do in the chat, and I will take care that your questions are answered. For any technical problems, again, use the chat window or write us at the displayed email address. So without further ado, I am honored to introduce you to our speaker for today, Maximilian Brockhaus. Maximilian, the stage is yours.
Yes, thank you, Andrea, for the introduction. Also a good morning or good afternoon from my side. My name is Max, and I work as a group manager at Fraunhofer IPT, and I will now show you what we have been working on in 5G-ACIA in the context of business return calculation. Andrea, could you please let me know if you can see my presentation now?
Now I can, yes.
Now you can, okay. Very good. All right. Yeah, as I said, I work as a group manager at Fraunhofer IPT in the Department of Production Quality. And during my research, I mostly focus on the question, how can we evaluate the technological benefits of new technologies, for example, like 5G, in terms of how can companies utilize this technology to gain something from the use of the technology in their daily business. And this is also what we have been working on here in the white paper titled Business Value and Return on Invest Calculation for Industrial 5G Use Cases, focusing on the question how we can quantify what companies can get from 5G. We have compiled a white paper that you can also find on the 5G-ACIA homepage, and I will now in the next 30 minutes tell you a little bit about what we have found out during our work on the white paper. I would like to start with one question that has been bothering us for a couple of years now, which is, why doesn't every manufacturing company use 5G? I mean, this question is, of course, a bit provocative because the technology is rather new, and we've seen it with other technologies. Not every technology is adopted right away. But what we have found out when we discussed with companies from the manufacturing vertical, that in a lot of cases, they do not really know what they can gain from it. What they can gain from the technology in their daily business. What does, for example, a manufacturing company get when it employs industrial 5G use cases? And yeah, in the 5G research community, this has been quite some headache in the last couple of years. We all know that 5G has a lot to offer. We have these three main characteristics, eMBB, URLLC, and MMTC, that have been very broadly known in the communications technology. And we have also derived a lot of use cases already where we can make use of the technology in manufacturing. This can, for example, be in predictive maintenance. We can have augmented reality use cases to distribute information, for example, on the shop floor. We can make use of AGVs, automated guided vehicles. We can increase our factory automation. So in theory, there's a lot that we can gain from the technology. So 5G has a lot to offer, but not everyone is ready to exploit it yet. We found a couple of statistics, or there is very many statistics focusing on why 5G technology has not been adopted yet. And this is a study here from Bitkom that said that one of the main reasons why companies are struggling with the adoption of the technology is a lack of understanding of the return on invest that they can get, unpredictable costs, and also a lack of technical use case understanding. So what does 5G offer, for example, in manufacturing environments to the end users? There are very many statistics expressing this concern from manufacturing companies, showing that, for example, a real business outcome needs to be graspable by these companies, and that there is the need for a robust investment case that needs to be underlined by quantifiable data, where a manufacturing company can really assess whether they get something out of the adoption of the technology, and if so, to which degree this fulfills certain business goals that they have. And from this, we have derived the objective of our white paper in 5G-ACIA, and this is stated here. We wanted to describe a pragmatic methodology that enables us to assess the business value generated by implementing 5G-based use cases in manufacturing. So this has been the guideline for the creation of the white paper. And in the last 2 years, we have been working with the partners of 5G-ACIA on the development of a methodology that I will present to you now in detail. And I will also show you how we have applied it successfully to 3 exemplary use cases. The main takeaway here for you is that we have been working on this with our IT and OT partners in 5G-ACIA, and we have already had a theoretical solution to calculate certain business benefits that can be achieved through the use of 5G technology. In the 5G-ACIA white paper, we have refined this methodology to make it more applicable to everyday use cases. Before we take a detailed look at the developed methodology, I want to explain to you how the methodology works on a higher level. We have defined that we would like to approach this in a stepwise manner. And to break this down, we said we first start with techno-economical goals. A techno-economic goal can, for example, be an increase in productivity of a manufacturing system. This is something that, for example, every production manager pretty much likes because they are always concerned with improving their daily operations. And for this reason, we said this is our first point that we want to address. We want to address techno-economic goals to make the benefits that 5G offers quantifiable. And we do want to quantify this with our key KPIs, with our key performance indicators that we have defined in order to measure to which degree a certain techno-economic goal is addressed. These KPIs are then calculated using KPI equations. And one thing that is important here is that these equations are very generalizable, so we can always adapt them to different manufacturing use cases. You will see this later on in the presentation. It's just important here to take away, we measure the degree to which our techno-economic goals are achieved by utilizing KPIs, which we calculate with rather generic KPI equations. And the input parameters into these equations are estimates that we want to identify by using expert estimated guesses or expert knowledge. I've broken this down into a graphic that we can have a look at now to explain this in a bit more detail. At the top of our methodology is always the techno-economic goal. So what do we want to increase? What do we want to achieve? In this case, we want to achieve an increase in productivity. As I said before, this is something that every production manager is always concerned about. We then say, okay, which KPI can be utilized to calculate an increase or maybe also a decrease in productivity? And these are KPIs that are used on the shop floor in a manufacturing system. So we want our processes to be more effective. We want, for example, our throughput ratio to be increased, as well as our worker efficiency. As we are here in the 5G context, it's important to note that throughput ratio does not concern a network. It concerns a production system. So how many good pieces do I produce within a work shift, for example? So here we have our techno-economic goal and our KPIs. And then we have our KPI equations, where we say we want to calculate these, we want to calculate values for these KPIs. Here you can see exemplary KPI equations that we have defined, as I said before. And what they use is they use an estimated impact of 5G technology. And this is where the methodology has been adapted based on industry needs. Before we started the work item in 5G-ACIA, we already had the basic principle of the methodology in mind. We have been working on this for quite some time now. And what we noticed is that it's very difficult to really measure certain components of these KPI equations. And this is where we said we need to make estimations. We need to, for example, conduct expert interviews to give an estimated impact on the use of 5G technology, or that the use of 5G technology has on certain parameters of or certain components of our KPI equations. The key question for this is always, what approximate impact does the use of 5G in the use case under consideration have on the coefficients of the equation under consideration? And this is, of course, something that is a potential weakness of a calculation, because we need to make these estimations and everyone can make their own estimations. So if, for example, we talk to production manager, they will have a different opinion on the positive impact that 5G has in comparison to, for example, a technician really working on the line, working on one machine, being responsible for one certain aspect of production. What's interesting here is that we always focus on the effect that 5G has on certain parameters. So for example, if we say, we estimate that through faster communication, more reliable communication, we can increase a 10%. We can achieve a 10% increase in produced quantity, or we can increase personal work time by 15%. These are exemplary numbers. I will go more into detail now. What's important to take away here is that we use these estimated impacts that 5G has on each coefficient of our KPI equation to calculate our KPIs, and then calculate the degree to which our techno-economic goal is achieved. Let's now have a look at how we can apply this developed methodology to use cases. So we have broken this down into 4 consecutive steps that always need to be executed in order to get to the business value calculation. At first, we need to specify the application that we look at. So there are certain use cases up and running in manufacturing systems, and some are maybe on a pilot line, some are in a conceptual phase, and some have already been deployed. In the first step, we select and specify which use case is to be assessed. What does the use case look like? In which technical state is it? What's the stepwise execution of the use case when it's applied? And also, what do we want to compare 5G to? So when we want to make an estimate of the achievable benefits of 5G technology, we always need to define a reference point that we want to compare it against. This is done in the first step of the methodology. So after this, we would have our use case characterized and described, and we would also have our legacy technology that we want to compare our technical solution against. In the next step, we select the goals that we want to achieve. So what are the objectives of the use of 5G? What do we want to increase? What do we want to improve? This in manufacturing is always very obviously very manufacturing oriented. So we want to, for example, increase our productivity or our quality, or maybe we want to decrease the rate of accidents that we have in manufacturing. This is where we have a predefined set of goals that are in theory achievable with the use of 5G. And here we define what we want to really address. In the next step, we look at KPIs that we can utilize to measure the degree to which these goals are achieved. So we have our predefined set here. We have also our predefined set of equations. And then we need to gather estimates from experts in order to make an assessment of these KPIs. And in the last step, this will then be utilized to estimate the degree to which the goals have been achieved. And in this way, we want to aim at creating transparency regarding the business value of the deployed 5G use cases in manufacturing. When we apply this to a exemplary use case, in this case, this is a automated valet parking use case. We first say, okay, we look at an automated parking operation based on 5G communication, and we compare this for the manual execution of the use case in comparison to the 5G supported execution of the use case. This is the first step here. Then we say, what do we want to achieve? We want to achieve an increase in the technical goals of mobility and productivity, and we want to increase our net present value, want to calculate our amortization time, and also address OPEX per product so that we can create transparency regarding technical and economic aspects. We then, in the third step, determine which KPI need to be calculated and which estimates we need from an expert. And then in the end, we calculate our KPIs and we calculate the degree to which we achieve our goals. So to summarize this, we always start with our technical goal. We then say what are the KPI that we can utilize to calculate in which way we achieve this goal, which expert inputs do we need to achieve this goal, and then the degree to which we really make progress here and really address the goal that we have selected in the first place. And we have applied this in 5G-ACIA to 3 different use cases. All in all, they are all from the manufacturing domain, but we have a little bit of a speciality here with the automated valet parking use case, because this has been developed together with an OEM. And here we are actually at the stage after manufacturing. So a car has been produced and is automatically driven from the production line to a central parking space in the production facility. Nevertheless, this is all manufacturing related, and with these use cases, we can really show how the methodology can be applied in order to quantify the business value. These three use cases are also described in the white paper, and I will explain them in a bit more detail now. So the automated valet parking use case, that's the one that I exemplarily applied the methodology to here already. The automated valet parking use case is already implemented at the OEM that we have been working together with. And they deployed this use case to transport the cars or the passenger vehicles from the assembly line to a temporary parking spot in the production facility. Currently, or in the past actually, this has been done by human drivers who pick up the car at the end of the at the end of the assembly line and then manually drive it to the parking spot. And the company deployed a 5G network and a automated driving mechanism to automate this parking procedure. And what they or what we developed together is that we want, or the idea that we had is that we want to show the increase in mobility and productivity which are to be achieved through the use of 5G. So in this scenario, the company more or less tried out the solution and then reached out to us, and we together had a look at what does the company gain, well, what did the company gain since they deployed the use case. And as I already said before, we also calculated the net present value, the amortization time, and potential changes in OPEX. The second use case is an AGV use case, an automated guided vehicle use case. AGVs are used for intralogistics purposes in manufacturing scenarios where they transport goods from machine A to machine B. And for this use case, we made use of a 5G-based communication that controls an entire AGV fleet and transports goods between the individual stations of the production facility. For this use case, we also targeted an increase in mobility, productivity, and also safety through the use of 5G. And in the final use case, a milling use case, there was a closed loop control system implemented, making use of wireless communication to continuously monitor the milling operation. This was done for a turbomachinery workpiece. And in this case, we targeted an increase in productivity, quality, and sustainability. Yeah, that's the three use cases. What you can see is that they are all from the manufacturing domain, but they are all focusing on different aspects of the use cases or manufacturing systems. And this is also the strength of the methodology. We can seamlessly transfer the application of the methodology to different use cases. We do not need much time to transfer the methodology. We can pretty much apply it to any use case that has a relation to manufacturing right away. Because we make use of these estimated inputs for our methodology, there is really low effort to make a first assessment of new use cases really quickly. So now we have had a look at all three use cases that we evaluated, and the evaluation results are shown here. Before we go into the results, it's important to note that these are exemplary use cases and also exemplary numbers. We have applied the methodology in different scenarios, and the numbers that are published in the white paper have an exemplary nature. So these are not specific numbers, especially not the ones from the OEM that we partnered up with. They are just calculated to explain how the methodology can be applied. What you can see here is pretty much the result of the stepwise application of the methodology that we've seen a couple of slides ago. Here we focus on the automated valet parking use case. And as I said before, the two technical goals that have been selected are mobility and productivity. So in this scenario, the company already employed the use case, and they wanted us to check how mobility and productivity are influenced by the use of 5G. So this defined our goals here. We have then defined an evaluation scenario where we in detail describe every step of the use case. So how is the use case executed? And based on this, we have selected our KPIs from our predefined list of KPIs that we have compiled in the past. Here you can see the selected key performance indicators that address the goal mobility. We said we look at material handling mobility, we look at on-time delivery, and we look at space productivity as well as mobility efficiency. And for each of those KPIs, we made adaptations to the generic KPI equations that we already had. And then in expert interviews, we looked at each coefficient of these KPI equations and made these estimations whether there is a potential impact or not. So for the first two KPIs, we see that there has been no impact estimated. But for space productivity and mobility efficiency, we said there is very likely a 90% increase in space productivity and a 50% increase in mobility efficiency. And if we go back a couple of slides, we see that here we use these estimated impacts to quantify the effect that 5G has on each coefficient of our KPI equations. And this is how we came to the result of 90, respectively 50% increase for our KPI values. For productivity, we looked at effectiveness, throughput ratio, and work efficiency of our automated valet parking system. And we said that there will likely be no impact for effectiveness and for throughput, but for worker efficiency. And we estimated this to be roughly 30%. We conducted this with interactive interviews, interviewing a process expert on the use case, asking them detailed questions. So what do you think will be the increase of how much a worker can get done when they use or when the automated valet parking use case is applied? And here, after some discussion, we said, okay, we put in our estimations, we calculate this to be 30%. So now we have our KPI values calculated, 0, 0, 90%, 50%. And this in the next step is utilized to calculate the degree to which we achieve an improvement or a change, in this case it's an improvement, in the goal mobility. So we said that we look at material handling mobility, we look at the other KPIs, we put in the values, and here we use an average to calculate the impact. So our overall increase based on 0, 0, 90% change, 50% change is 35% improvement in mobility that is expected. This is the most basic approach to calculate the degree to which a goal is achieved. We can also use weights, of course. If, for example, we say we especially have a problem with on-time delivery, so we put a high weight on this when we look at mobility. so that we refine the methodology further. This can all be adapted. So there's a lot of room, of course, to manipulate the calculations. Our goal is always to create transparency and to make it apparent what we calculate and how we come to our results, in this case of 35% improvement in mobility. We've also conducted this for our other use cases in detail. So here we can see that for the AGV use case, we said that we, in this case, increase our material handling mobility and our on-time delivery, but we say there's no impact on space productivity. And we also left out the other KPI that we had here, which is the mobility efficiency. Then we also said we look at productivity, where we expect 5% increases for effectiveness and throughput ratio. And we also say that we increase our safety aspects because we want to achieve a reduction of mean time between failures by 5%. So if you put all, if we put all of this into the equations that we have for our goal calculation, we would also see here that we can improve mobility, productivity, and safety of our production system by deploying 5G for the use of AGV use cases. Here we also have the results of our milling use case. This is pretty much the same procedure. What's interesting here is that we have negative changes. And this is also something that's, that needs to be taken into consideration. In this case, negative is not bad. In this case, we want certain things to be negative. So here we have a comparison, for example, of quality. We want to increase our quality and we want to decrease our rework ratio. So in this case, we need to, or it becomes apparent that we need to differentiate between positive impacts that we have and negative impacts that we have. We defined this in our methodology to be the direction in which we want to change certain things. Of course, we do not want to increase our rework ratio. We want to decrease it, while we want to increase our quality ratio and not decrease it. This is also something that the methodology allows for. We do not only look at increase of certain things, but also decrease of certain unwanted things. If we look at the results, we have compiled them here. For the automated valet parking use case, we have calculated, as I said before, this 35 and 10% increase in mobility and productivity. We also said that there is a positive change in net present value by roughly 50,000 euros. We calculated the amortization time to be 7 years. And we also said that we can reduce OPEX per product, so per car, by 255 euros in total. As I said before, these are only exemplary numbers, just to give a rough estimate of what we can do with the methodology if it's applied to an automated valet parking use case. For the AGV use case, we calculated these positive changes here, 10% increase in mobility, 3.33% increase in productivity, and 1.6% increase in safety. And for the milling use case, we said that we increase productivity by 2.33%, quality by 30%, and safety by 4%. This is also all described in our white paper in more detail. What's interesting here is that we can make a real comparison between use cases. So for example, if a company that does all three things, that builds certain work pieces, that uses AGVs for intralogistics, and then has something like an automated valet parking use case, they can make an assessment of where they want to focus on with their 5G activities. So in this case, it would be rather clear that the automated valet parking use case offers the highest benefits to a company. But for example, if a company says we have really, really high focus on quality, so for example, in aerospace manufacturing, this is really important. They can also say we also look at the milling use case because we want to really target this 30% increase in quality. Maybe we're not so interested in mobility, or maybe we're not even interested in productivity. We only focus on quality. And by this analysis, we came to the conclusion that we want to focus on, for example, a milling use case. So the methodology, of course, is only an estimation. That's always something that has to be kept in mind when it's applied. But in our opinion, it provides a very good first step to make an estimate of what companies can get when they apply 5G technology, what are the benefits, and where do they focus with their activities in the area of 5G. So all of this has been described in our white paper. I said it in the beginning, you can download this in the on the 5G-ACIA white paper. And I already mentioned it before, we have been working on this topic for quite some time now. Roughly in 2017, 2018, we started with the with asking us the question, how can we quantify the benefit of 5G technology? We have been working on this for 2 years now in the 5G-ACIA consortium, and we are also active in this area with our EU-funded research project TargetX. You can check out both the white paper of 5G-ACIA and, of course, our research project TargetX, where we also apply the methodology to 4 different verticals from 4 different domains: manufacturing, energy, construction, and automotive. And yeah, the white paper has been created in close collaboration with this project. If you're interested in this project, you can feel free to reach out to my colleague Niels and I, and also check out our project website. To summarize this briefly, we have developed this methodology as a rough estimate of what companies can get. And we hope that we can answer the question that I stated in the beginning: why do not all companies make use of 5G technology or make a contribution to addressing this issue? We are convinced that if there's more clarity and transparency regarding what's achievable when 5G is deployed, we can really make progress here and contribute to the broad rollout of the technology in industry.
Thank you very much, Maximilian. Very much. Sorry. There are a few questions in the Q&A and chat sessions, so I would like to read them. So the first one is in the Q&A panel. And Alejandro argues that this analysis seems to be generic, as it would apply also to VLAN. And as he argues that as most factories have already WLAN widely deployed, how would this analysis help them? And help them move to 5G instead of staying with VLAN, which should also be cheaper.
Yeah, Alejandro, thank you for the question. You are completely right. This is a rather generic analysis. And in theory, you can apply the procedure to Wi-Fi as well. Then, of course, you have different estimated impacts. So one aspect that then might become obvious is that Wi-Fi tends to have problems with handovers between different cells. 5G then would have a different impact than Wi-Fi on certain aspects. So if we think about productivity of AGVs again, we would probably come to the conclusion that 5G is of or has the advance the advantage here in comparison to Wi-Fi. But you can probably also apply this to Wi-Fi.
So thank you very much for your answer. And just as a further question from my side, but it's also a way to understand the next question that came into the chat. So basically, and correct me if I'm wrong, Maximilian. So when I install 5G, or I have in mind to install 5G in some use case, I might compare it with a solution that is already there, for example, Wi-Fi, and then what it will happen is that by having an estimate on how 5G is more reliable, let me say reliable, rather than Wi-Fi, I would be able to estimate also how much time, for example, an AGV would save by being still, just because it has to go through an handover or
Yep.
some of this. Yeah. So basically, by then summing all the times of all the AGVs and multiplying it by the time that they are working actually in the factory, you would come to an estimate in productivity, for example.
Yeah.
And
yeah, that's exactly right. Yeah.
Okay. So basically, I want to give you. I want to read this question that came from Jörg in the chat, which goes in this direction, I think. So he says, and also this is a little bit of a provocative one, but this is all based on estimates and only compares one technical solution with the manual one. How can we prove that the different technical solution does not have a better ROI? How can we prove that the estimates are real? And Niels answered that this method allows, of course, a delta calculation. You can use a technical benefit of 5G versus a legacy technology. And so basically, Jörg is arguing that this is still an ROI guess. What's your take on this?
Yeah, I fully agree with what Niels said. So when we talked to the companies that either are interested in deploying 5G or already have it deployed, Niels used the term chicken egg problem. That's exactly what this issue is. So we have to make estimations. We have to make educated guesses. And you can, as Niels wrote, only really make a detailed calculation after you have deployed this use case. This is what we, for example, have done in TargetX. But this is it takes a lot of time and effort, because you really need to define what do you want to measure. Then you need to measure, and then you need to evaluate. And you can, of course, only do this after deploying the technology. So I fully agree with what is written here. And I think Jörg's conclusion was it's an ROI guess. Yes, that's true, because you never really know the correct impact that, for example, 5G has on the downtime of AGVs. You can only make estimated guesses. But for this, we say that we combine the expert knowledge from manufacturing and from networking. And this is, as I said, an step-by-step interactive interview thing that we do, where we ask detailed questions on what the expert from the production domain thinks. For example, how many hours of downtime result from a lack of communication. And based on this, we can make our estimations regarding the improvement potential.
But still, if you have to do a guess, I guess you could say you would also introduce some margin of error that would allow you to still have a rough idea of the ROI that you would achieve and confront it to the costs of the solution that you are likely to buy.
Yes. Mm-hmm.
Okay, is there any other question? So I don't see anything in the Q&A panel or in the chat. So I'll give it another minute if somebody is writing. Otherwise, as I said at the beginning, you can always contact us via email. And if not, then you see here a nice LinkedIn QR code that you can scan to follow us. And now I'm seeing that Jörg is thanking us for the honest answer. I think Fraunhofer does a good job to research the improvements that then might be transferred to real use cases. So I guess a big shout out to you, Maximilian. And so thanks everybody for your time. Thanks for following this webinar. And as I said at the beginning, this is a series of new webinars. So stay tuned for the next 10th of October at 10 o'clock. So again, the webinar series is called 10 at 10. So you can't miss it. Bye, everyone. And once again, thanks.
Yes, thank you for the attention and the questions. Yeah, feel free to reach out if you want to discuss anything further.